Alright, so today what I'm going to do is I'm going to go through refprop installation instructions, and today is September 23rd, 2020. Every time I teach this class I basically have to update these refprop instructions for installation, and so I'm going to have this Word file. It's actually been updated from last time I taught Thermo 2, and I'll probably end up updating it again today. So what you can do is you can go to where you can find mini refprop. It's at this website, or you can just go to a Google window and you can just type in mini refprop and it'll take you to a site like this, and then you click on it and you go to this site, which is the same as directly going to this site anyway. So at this point you can read about mini refprop. It's a free version for students, essentially. Basically, the people who developed this have been very kind to students and educational institutions. And so what you want to do is you want to click here and install that. So I'm going to try to adjust my windows so you can see what's happening. And what it's done is it's downloaded this miniref.exe. All right, so we're going to need to execute that once it's finished downloading. Looks like it is finished downloading. What I like to do is I like to look at it in the folder, so show in the folder. And this is a look at my basically downloads folder. And there's only one. I cleaned it out before I did this. And so we can double click there and it'll say, do you want to run this? And you say run. Welcome to mini refprop setup wizard. Do you want to install this? Say sure. And there's a number of things you can take a look at. It's put out by the National Institute of Standards and Technology in Maryland, but I believe the people who support this are in Colorado. And we'll just click next. It suggests to put it in a folder, and that folder is mini-refprop, and I'm going to remember that name. Okay, I usually just take the default, say yes, okay, and to continue, click next. If you would like to select a different folder, no, I think we're going to just stay with that folder, and then click next and install. And at this point we can launch the mini refprop. That's a pretty good idea. So we'll go ahead and say finish. And I'm going to try to make this window a little smaller and make it fit on the screen. There you go. So it launches this mini refprop. You can see the name mini without the dash, refprop sometimes with the dash, sometimes with the dash. And I'll just set it up a little bit and play with it. You have file, not much to do there. There's a couple things, but units I always play with because I like to work with the degree C, and I like to work with, and this is a little tricky, I have to scroll up to get to kilopascal, but I could leave it megapascal. So for right now, let's just leave it megapascal. But if you could scroll up and work in Pascal, kilopascal, bar, ATM, millimeters of mercury, blah, blah, blah. Lots of units, just like you might expect for a piece of software in 2020. Leave that in megapascal, degree C. I changed my mind. I'm just going to go with standard SI, Kelvin, and megapascal. Volume in meter cubed, mass in kilograms, moles in kilomole, energy in kilojoule, and more. Okay, for viscosity, thermal conductivity, a lot of these things we don't need or use for Thermo 2, but it's out there. And then on the options, you can play with the reference state. If you're dealing with refrigerants, that's one that usually trips up students. They say, hey, this software is garbage because it's giving me a completely different value for enthalpy than my textbook. Well, it's the reference state. That's the difference. And then often I play with properties. So temperature and pressure, density. I would rather not play with density, but specific volume. And internal energy, yes or no. I like enthalpy and entropy, the specific heat, constant volume, constant pressure, Cp naught at low pressure, ratio of Cp's, that's K, the gas conductivity. There's speed of sound, blah, blah, blah. But down here's quality. I wish they had quality right after entropy or right after temperature, pressure, because a lot of times we're working with steam and it's changing phase, but that's where you find quality in the list. And there's even other properties over here. And since we just finished the exergy, you won't find exergy in this table here. You won't find it in this table of properties like the Prandtl number, thermal conductivity, viscosity, and all that. You won't find the rate. This is like chapter 11 in our textbook. It's all about the relationships of thermodynamic properties, and they're often expressed as derivative of this property with respect to that property is equal to this derivative of that property with respect to this property, etc. There's a lot of things on here, isothermal compressibility, blah, blah, blah. But I wanted to get over here all the way to special, because here's flow exergy. So if you wanted to deal with flow exergy, you could deal with flow exergy right there, but you'd have to search for it to find it, but that's where you find it. So, I wish flow exergy was a little more prominent, easy to find, maybe up in here, but that's okay, we can deal with it. So these are the pressure, temperature I like. Let's be done with this, call OK. The other option that sometimes I'll play with is the order of the properties when I'm playing in a table. And I like pressure to go before temperature. That's just me. And then if you chose density, it would go next. But if you didn't, it would leave that out. Specific volume, internal energy, enthalpy, quality, or enthalpy, entropy. Way down here is quality. I really like that to come up. But you'll get tired of playing with this, because I think if you restart, you'll have to reset the property order. But there you go. Maybe you have a preference. Maybe I should explore that better. And let's just be done with that and click OK. All right. Any other things here? Well, save current options. Maybe I should do that. Save my current options. Default, let me put my initials RM, and that will be my default options. Okay. Now, substance. You can do mixtures and all kinds of things, but predefined mixtures. But let's just do a pure fluid, a single component. And you can read the notation here, but it's not as important for us right now. And we get water. We get refrigerant 134A. We get nitrogen and helium and methane and some other ones, but water is the one we're working with right now. So we'll just click OK. And you can do a bunch of calculations, different things. I just want to make a table of specified points where I know some of the inputs, and then it calculates the other properties of interest. So these are the properties that I selected. Notice density is not in here, and quality is the third one, and pressure is the first one. And I may be interested in saying, well, I'm interested in saturated liquid, so I'm going to put quality of 0. And at a pressure of, I don't know, 20 kilopascal. Well, that's 0.020 Pascal. Now those two properties fix the state when you hit return. There's the temperature. What is that? 333.21 Kelvin. And that'll be the saturation temperature at that pressure in Kelvin. You could put degrees C if you want, but I didn't. The specific volume, enthalpy, entropy, and flow exergy. Okay. Now, since I may be interested in boosting the pressure from 20 kilopascal up to 2000 kilopascal through a pump, and I need another property to analyze going through that pump, well, you could just grab this entropy right here and say it's going to be a reversible flow through that pump. So I'm going to copy, Control C that value. I'm going to move my cursor down the cell, Control V, paste. And let's see what it says. Do you wish to continue the calculation? A warning, pressure above upper limit really? Oh, no, I don't want to continue. You can tell I'm used to working in kilopascal. So that's not 2000, it's 2 megapascal. There we go. So now we find that, yeah, it complained a little bit, but it comes back with this value of temperature. Notice it's a little higher. Or is it? I need to put my glasses on. Just a very little bit higher, 0.08 degrees, less than 0.1 degree Kelvin temperature increase. It moves from saturated liquid to subcooled liquid, or compressed liquid if you call it that. It really is about the same specific volume. The enthalpy has gone up. Looks like it's an increase of about, what, 2 kilojoules per kilogram. The entropy is what we fixed, and you can even look at flow exergy if you're interested. So why did I play with these numbers? Well, I'm going to beat up this problem some more later, but you can see how this runs. So we're running it, and it's running on our computer. What I need to do is move out of here for now. Okay, go back to my instructions. And so we ran that mini-ref.exe. It set it up in this folder. I didn't go and verify that folder. I should do that to show you. Let me do that. Come over to, well, I'm in downloads. Go to documents. No, go to C drive, sorry. C drive. And in C drive, program files, 86, so there you go, this one. Open that up, and you should find a new folder that it created. And there it is. It's mini-refprop, just like they said the name would be. We can open it up and take a look. Inside this fluids folder, they have the water, refrigerant, propane, oxygen. These are files that you need for those properties. And there it is. So with that, let me go back to our installation instructions. We verified, we accepted the default folder. We verified it was there. Our desktop application shortcut was there, and it ran. Maybe scoot this over. Wow, there's a lot to scoot over, but let's try and scoot this over as well, and this well. And right here, I have a little desktop icon set up, so we can run it by clicking that desktop icon. Let's go back to our installation instructions. Now, down here, if you want to run refprop in Excel, like I do, and like I often do, there's a little more work to do. Well, you can go to this github.com, nist.gov, refprop wrappers, blah, blah, blah. So let's just go ahead and copy that. And once we're there, we're going to download 2 files, a refprop.xla, and put that into my recommendation, a brand new folder that I have already some add-ins in, but this will be another add-in, and put it into the C add-ins folder. If you haven't created a C add-ins folder, create it, and that's my recommendation. Put this refprop.xla, that'll be the refprop add-in, and then download an Excel file, refprop.xls. It's like where you would work in that file, and put it in a folder where you want to work. Maybe you put it into this class, me4293, something like that. So I'm going to leave this page, but kind of remember that this is the add-in, and you want to put it where you can find it. And then this would be another file you download from the same site, and it's basically an Excel sheet. And let's do it. Okay, so I have copied this, and I go to my internet, and I just do a paste and hit return. And there it is. So we have some NIST refprop wrappers. Okay, well, here's a README if you want to read it. That's that XLA, that's for our add-in, and this is for our other one. Now, this one is update C, blah, 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 refprop 9.1. We're running 10, so we want to run with this one, not an older one. So I'm going to click that. And I'm not an expert at this, and probably somebody's going to tell me how to do it better, but this is my file, and I don't know why, but I just click View Raw. And you can tell it's starting to download right here. And so it downloaded just like it downloaded this mini ref.exe, which we ran, I like to just open it up and show in the folder. And there it is. And there's a little box in the upper right corner which shows that it's an Excel add-in. It's hard to see, sorry, but that's the little notation that they use, illustration, that this is an add-in. Okay, so it's downloaded. Before we move it, let's go back here and go back and do the same for this Excel file. So click there. I wish I knew more how to use this software, but I just know how to get it to work, to download, and it just downloaded the XLS, so that's the Excel file itself, refprop. And I'm going to go and I'm going to show in folder, and now we'll get both of these. Whoops, maybe I'm not done downloading. Was I done downloading? Let me do it now, show in folder. Well, I don't understand this unconfirmed download report, but I'm going to do this. I'm going to Control X or cut this one because I don't really need it to stay there. I'm going to come over to the C drive, find my add-ins folder. Inside my add-in folder, again, I have a lot of add-ins because of other things, and so now I'm going to do a paste. And so now refprop, as that add-in has been placed in my add-ins folder on the C drive. Oops, I should have scooted that down to show you. So it's in the C drive add-ins folder. There it is. Okay, let's go back to our downloads. This is a download. The only one is Excel, so I'm going to cut that. I'm going to come over to Documents, and man, you see all my junk. Sorry about that. And I'm going to open up this play folder and paste it right there. All right. So we have the two files downloaded from GitHub that we wanted. Let's go back to the instructions. And now that we have them in the add-ins folder or my play folder in my class, wherever I want to work with it. Now, what you can do is you can open that and click on Enable Editing and click Enable Content, since my system protects the computer from bad downloads, so you just have to be careful of that. And then under Excel, in the File area, go to Options, Add-ins, Go, Browser. All these steps I've covered in a previous for adding in different add-ins, but now we're going to do the same process for the refprop add-in that we just downloaded. Okay, remember again, this small square in the upper right corner indicates it's an add-in file, blah, blah, blah. So let's do that. Let's go ahead and open up an Excel file, the one we just downloaded. I put it in this folder called Play, so you don't have to see all my other junk. And I'm just going to double click, and it's opening. Okay, so refprop opens. It's in a protected view. So the protected view, be careful, files from the internet may contain viruses, blah, blah, blah. I'm going to go ahead and enable editing. There we go. So also security warning, macros have been disabled. Well, I want to enable macros because it's going to have to look up and do that inside the code. Well, there's a couple places here. There's a tab for a summary tab. Eric Lemon is the key guy. He's in Boulder, Colorado. This is the welcome window right here. And it makes sure that these numbers are close enough to match or both version 10. Sometimes you have to find an old DLL version number and destroy it or delete that file. Okay, so there's a lot in here. Welcome. There's a bunch of stuff. They kept updating it. Now it's on like version 10. And all about units, fluids, more here than we have time to go through. Let me move over to here. This is an important table if you're playing with different units. I like to work with SI and C. The shortcut is just call it C, first degree C, but you have megapascal, and all these are the default units when you're feeding it pressure and you're feeding it temperature. Or you can just use SI. This is my second most common. Both of these are on a per unit mass basis. If you want to do a molar SI, then there you go. And if you want to do and then over here is English. So if you want to use the United States customary system of units, you could. Degrees F, PSIA, BTUs per pound, etc. And other. There's a number of units that are defaulted. Again, I like this one. I use it a lot. Okay. Then fluids, whole bunch of fluids. Now we get the mini refprop, so we don't have all these fluids, but and we don't really have a lot of predefined mixtures of fluids. But here is a start here. So your version number is 10. Fluid name, methane, pressure, temperature, using degrees C, SI with degree C as a unit system. And let's go to available properties. Now we got more available properties and discussion. Looks like things aren't working like they should. I'm gonna have to check into this. But I'm going over and going over, and that's all mixtures, unit conversions, blah blah blah, and then this is checksum. So right here is an important table, and this section right here is important. So if the value that is 2 cells to the left, okay, this is 1 cell to the left, 2 cells to the left, that's 10.0.0.02, is less than that in the adjacent cell, that's 10, it's not. After pressing Control Alt F9, I'm going to press Control Alt F9, and it updates these values. Then you are, get a scroll over, then you are not, blah blah blah, keep scrolling, you are not using the most recent refprop DLL file. Search your computer for some old DLL files and get rid of them and delete them and look everywhere. Okay, well, let's go back over here. That doesn't seem to be a problem at all. It tells me the location of my code right here, and this is what I don't like. There should be some numeric values compared with the hardwired values, and then a comparison of the difference, and those should be close. And so I have to take a look here. It just says refprop M, tell me the molar mass for air. That's a call in refprop. And the error that it's coming back with is something like error in opening file for component 1 air.ppf in the path. And then I got to scoot this way over to read that error message. I really don't know how to read that message better. In the path, C program files refprop. But we didn't put it in refprop. We put it in mini-refprop. So this is a little annoying. Let's go back to my instructions. Well, what I need to do is I need to tell where the add-in is. So that I haven't done, so it's not running properly yet. So what I have to do, let's scoot this down so you can see it, is I go to File, then I come all the way down to Options, and once I'm in Options, I want to go to Add-ins. Now that it's selected, it'll change this interior part. And then I want to go to Go. And I don't care about these old ones. I should have gotten rid of those anyway. I should have gotten rid of them when I cleaned it up. But I want to go to find where I have that brand new add-in. So I know it's going to roaming, blah, blah, blah. That's why I need to, I go to my C drive, I go to my add-in folder, and I open it. And there's a bunch of other add-ins, as I said before, they're in there. But this is the new one that we just put in here. So I'll select it by highlighting it. and click OK. And then it should have shown up right here, refprop addins. OK. And then I'll hit OK. And it still doesn't like that it's in the refprop folder. Okay. Well, what I'm going to do is I'm going to go back over to my mini refprop folder right here. And I'm going to change its name. And I'm going to hit rename. And I'm going to change it to refprop and hit return. And could not be completed because a folder or file is open in another program. Well, let me come over here and stop it. So I got rid of that. Let's try again. And it looks like it ran it. Let's go back over here. So C program files x86/refprop. And I'm just going to hit, put in the number 3 in a cell and hit return. Still no go. Control Alt F9. Okay, finally. Now, because we have mini refprop, we don't have a lot of different fluids. Like we don't have argon. You can see argon right there, or ethylene, or R32, or ethane, or ammonia. But we do have some, like this one right here is for air, and this one is asking to make an evaluation of R134A. We have that one. And this line is asking to evaluate a property for oxygen. So finally we're getting it to run, but they're not finding the routines. So what I'm going to do is I'm going to shorten that back up to like it was before. And you can see that the NIST value that they think that the software should return compared to the actual return when it's running here is coming back % difference 0, % difference 0, % difference 0. And they even show you the function in the text. This is our function that was typed in over on this cell. And this is the function for the argon, and so they can't find argon, so it complains. But it does find for 134A, finding the pressure as a function, the temperature and density, etc. So there you go. Looks like we're off and running. And that's the checksum tab